Hey, hi and welcome back. In previous video, which was part 1, we completed 2 phases of hardware development process. Now in this video, which is part 2, we will complete rest of the phases. Okay. So now let's start with this video. So again, you already know the learning objective and these are the phases about which you will learn in this video. So now let's get back to the block diagram and let's complete rest of the phases. After that, the next phase is hardware architecture or block diagram. Okay. So starting from this phase and rest of the phases will be actually handled by the hardware design engineer. Now based on the inputs provided by the client or based on the specifications which client want to incorporate in the product, based on those specifications, it's actually the responsibility of hardware design engineer to create a block diagram for the product. So he's going to take the decision what will be the different blocks that will be present in that particular product whose PCB hardware design engineer is going to design. Okay. So for example, let's say that there will be power supply block, then controller block will be there, then let's say some LEDs will be there, some switches will be there. So likewise, based on the requirement of product, he is actually going to divide that entire system into different blocks. Okay. And this is how basically it's going to create the block diagram for that particular product. And in the same way, no matter what kind of product you will work on, you have to create this type of block diagram for all your designs. So that's all about this hardware architecture or block diagram phase, in which the hardware design engineer is going to create the block diagram, and from the block diagram you are going to get a brief idea about that particular product or the different blocks which will be present on the hardware. After that, the next phase is schematic design. So in this phase, hardware design engineer is actually going to do the detailing of different blocks which are present in the block diagram. Okay. For example, if there is a power supply block, then in this phase, the hardware design engineer is actually going to create the schematic for power supply. He is going to take the decision what type of IC will be present in that particular block, then what will be the different components which will be connected around that IC. So all that decision will be actually taken in this phase. So here he is going to do the detailing of each and every block, like power supply block, and if there is a controller, then he is going to create the circuitry of that controller. He is going to select the ICs, then different components which are connected around that circuitry. So all those things related to circuit designing will be done in this particular phase, so which is actually the schematic design phase. After that, the next phase is layout design. And in this phase, the hardware design engineer is actually going to create the layout. Now, one thing that I want to tell you here is, if you go for a big company, then in that company, most of the time, the schematic design will be created by some other person, or there will be different team for that. And this layout design will be created by some other people, or there will be some different team for that. But if you go for a small company, then it will be actually a responsibility of a single person, and he is going to create the block diagram, he is going to create the schematic design, he is going to create the layout design. Okay, so all those stuffs will be actually done by the single person. But if you go for a multinational company, there will be separate team for schematic design, there will be separate team for layout design, then for different phases there will be actually separate team, and the task will be actually divided between that team. Okay. So again, in this phase, it's actually the responsibility of layout design engineer to create this type of layout. So this is basically the layout of hardware that we are going to design in this training. Okay. So here again, you need the inputs from mechanical design engineer. He is going to tell you at what location, for example, the DC power jack will be there, at what location you need to provide the mounting holes, because these are basically the points which mechanical design engineer is going to tell to the layout design engineer. And based on that, he is actually going to create the layout. For example, if you see in cell phone, there will be there will be a position of camera. Okay, so the position of camera is actually decided by the enclosure designer. Then there will be position for flash, then there will be position for proximity sensor. So position of all these peripherals are actually told by the mechanical design engineer to the layout design engineer, and based on his inputs he is going to place the components on the PCB, and accordingly he is going to create the layout. So everything related to layout will be done in this particular phase. After that, the next phase is PCB manufacturing. Now once your layout is ready, later the CAD software that you are using, or like in our case we are using Eagle software, right? So using the CAD software, the layout design engineer is actually going to generate one file which is called as Gerber file. Okay, and that Gerber file will be sent to the PCB manufacturer, and once the Gerber file is sent to the PCB manufacturer, later after, let's say, after 1 or 2 weeks, you are going to receive the PCBs. So that's basically the PCB manufacturing phase. Okay. After that, the next phase is component sourcing. Basically, you know, this PCB manufacturing or PCB ordering and component sourcing, these two things are actually going to be in hand. So these two things are, or these two phases will actually work in parallel. So when we order the PCB, at the same time we are actually going to start ordering the components. So these two phases are going to be in parallel. But you know, there was actually one phase on which I was working on a product. There we sent the PCBs for manufacturing, and we got it around within 1 or 2 weeks, but the components were actually, we didn't receive the component even after 1 month, and this was actually during the COVID period. So such situations may arrive, and it's actually the responsibility of project manager to how to handle this kind of situations. And accordingly, based on these kind of situations, the project manager is actually going to do the changes in the project plan. And you know, these things are actually part of product development life cycle, and project manager generally provide extra bandwidth, and he knows these types of things are going to happen. So considering that, he is actually going to you know, provide an extra period for each and every phase. So in this phase, all the components which are present on your hardware, all those components will be ordered. You know, once the layout is completed, after that there will be actually one option in the CAD tool which is actually BOM option, which stands for bill of material. So with the help of this option, you know, you can generate a bill of material. Bill of material means there will be a list, and in that particular list, all the components which are present on your hardware, all those components are actually listed. So in this phase, you are going to order all the components which are present on the hardware. After that, the next phase is PCB assembly. Now in this phase, all the components will be actually soldered on the PCB. Now again, the decision comes whether you have to solder the components manually or those components will be soldered using the machines. Now if your product that you are designing or the hardware that you are designing, if it is very complex and if it includes packages which are very complicated to solder, then generally that kind of PCBs will be actually not soldered manually. That kind of PCBs will be sent to a separate company which is called as EMS, and EMS, which stands for Electronic Manufacturing Services. And in this EMS there will be pick and place machines, and using those pick and place machines, the components will be placed on this PCB, and it's actually the responsibility of EMS to solder all the components on the PCB. But if your design is not that complex and the components which are present on the PCB are easy to solder, then in that case, generally the company do the soldering manually. After that, another point is the quantity. If the quantity of the product is very high, for example, let's say 1000, 2000, in that case, you know, generally the company will actually send the PCBs to the EMS, okay? Because in such situation, it's not possible to solder, 1000 quantity manually. So generally in such situations, the companies are going to send the PCBs to the EMS and get the PCBs soldered in the EMS. But sometimes, you know, if the product is very complex or the hardware is very complex and it's not possible to solder the PCBs manually, especially in case of processor based hardware. There it's not that easy to solder the PCB manually. So even if the quantity is less, still the company will actually send the PCBs to the EMS, okay, and EMS will do the soldering of all the components which are present on the PCB. And whenever we deal with the EMS, there will be a huge cost, okay. So you have to take the decision during the project plan itself, if you whether you have to do the soldering of the components manually, or you are going to send the PCB to the EMS for automatic soldering purpose. So that was all about the PCB assembly phase. So once the PCBs are assembled, then the next phase is PCB testing and troubleshooting. Now in this phase, the hardware design engineer is actually going to check all the blocks present on the PCB, okay, and he's going to make sure all the blocks are working as expected. So he's actually going to do the thorough testing of the entire PCB. Now generally, once the PCBs are tested, what companies do, they're actually going to run the hardware continuously for 2 to 3 weeks, okay, and they are going to keep the hardware under the observation. It actually depends on the type of hardware or the type of product. Some hardware they are going to keep some hardware running for continuously for 1 or 2 weeks, or some hardware will be kept running for 1 month, 2 months. So it actually depends on the hardware. But in this phase, the entire testing and troubleshooting of the hardware will be done. After that, the next phase is product deployment. So once the hardware is tested and everything is perfectly working, then the product will be deployed in the field by putting it in the enclosure. So that was all about the hardware development process, okay, and I hope that now you have the absolute clarity about the different phases which are involved in hardware development process, and what happens at what phase. Alright, so that's what I wanted to tell in this video, and I hope that you enjoyed this video. Now in next video, we will start with hardware block diagram.